Welcome! In this series of videos, we will cover the design and implementation of a project, from initial design through coding and development to testing, using the PowerBasic Windows compiler. Today we will look again at the design of alternative graphic user interfaces, GUIs, to make your application stand out. This was our application at the end of the last video. We've created a dialog which has a gradient fill, as you can see on screen. When the dialog is resized, the gradient is automatically redrawn, all the way up to maximizing on your screen. What we're going to do today is we're going to put something on this dialog which the user can click on. In standard Windows applications, you could do this with a menu or perhaps buttons or Windows controls. But we're going to do something a little different today. We have created in the code folder a subfolder called Graphics. And in that Graphics folder, we've created a number of bitmaps. We're going to use the graphics control to place these bitmaps with a mask onto the screen to allow us to display buttons which look hex-shaped. So let's have a look at the code. If we have a look at the callback function, the event handler for our dialog, which is in here, we can see that these are all the events that are triggered when the dialog is shown. In the WMPaint event is our function gradient fill graphics control. This is the function that puts that gradient onto the dialog. Once this has been drawn on screen, we'll want to draw our hex-shaped buttons. So we're going to create a new function called draw hex menu. And there is the call to our new function with two parameters. The first being the dialog handle and the second the handle of the graphics control itself. So here is the skeleton of our new draw hex menu function with its two parameters. So as we saw in the Explorer window, we have a number of bitmaps that we're going to be loading. On this gradient screen, I want to put 7 hex buttons, one in the center surrounded by 6 around the periphery. So there's going to be 7 buttons in total. And once these are placed on the screen, we're going to capture the mouse click that the user clicks on and work out which button they've actually clicked on. So we're going to have to put some code in here first of all to draw each of these hex symbols on the screen. So we will create a number of local variables to allow us to do that. So here are our local variables. We have a file handle which we'll use for opening our bitmap. We have 2 variables, one for the width and one for the height of the bitmap. And then we have handles for the bitmap and the mask. As we're going to be drawing onto the screen, we want some removal of parts of the bitmap we don't want to be seen. So we're going to use a mask for that. And then we have the name and path to both the bitmap and the mask. And then we have an X and Y location to which we're going to place our first button. And then finally, we're going to be using a pointer to an array. We'll cover that later. So our first task here is we're going to dimension a local array. This is going to be a point array holding the X and Y coordinates of the top left-hand corner of each of our bitmaps. This is our long locations array. We are at the moment planning on having 7 of these hex buttons on the screen, so we're going to set that as a constant called max hexes. This way we can start off with 1 button and work up. Secondly, we're going to have a string array called icon. This will hold the name and path to the bitmap image we're actually processing. So as you will have seen in the folder, we have a file called mask_big.bitmap. This is the mask we're going to be using for each of the buttons. Although we're going to have 7 buttons, I've only created 2 icons, one called hex1 and one called hex2. Ideally, you'll want a different bitmap for each of the buttons, so the user can determine which one to click on. The purpose of this piece of code is to work out how wide and how high each of the bitmaps actually is. As all the bitmaps are exactly the same size, we only have to do this once, and we can do that on the mask. So we're opening the file, we're pulling back 2 pieces of information, the width and the height, as numbers. and we're storing these in the appropriate variables. And having done that, we can use the graphic bitmap load function. This is inbuilt to PowerBasic and is one of the graphics control commands. This will load our specified graphic for the width and height, and load it into memory and return the handle, in this case bitmap mask. Next, we will specify the coordinates on the graphics control that we wish to start drawing. This is our X and Y coordinates. We will start 100 pixels in from the top left and 100 pixels down from the top of the window. Next, we're going to save those coordinates into our location array. This array is eventually going to be 7 elements in size, but we'll just populate the first element for the moment, setting the X and Y coordinates to the values we've stored in XStart and YStart. Next, we're going to use the arrayAssign command to populate our icon array with the path and name of the graphic we wish to load. In this case, we're just loading Hex1 into the first element of that array. So before we go any further, we'll want to nip back to the beginning of our code to specify the constant which we're going to be using, in this case, max hexes. So there is our new constant now set up with the value of 7. We will change that temporarily to the value of 1, as we just want to draw 1 hex for the moment to start us off. As there are going to be 7 different hexes, we're going to give each of these a constant so we know what they are. Our first hex is going to be the one to allow us to exit the application. After that, we can have other hexes for doing different things. And storing them in this way allows you to document as we go. However, using constants like this allows us to give a name to these numbers and makes the code that bit more readable. So let's go back to this function we've been coding up. So after assigning the name of the bitmap we want to load, we're going to be doing a for next loop, from 1 to the maximum number of hexes we're processing. This is currently only 1, but it will eventually be 7. So here is our for next loop. And for each iteration of this loop, we're going to be calling a new function we haven't coded yet called drawHex. This function will have the job of drawing the hex on screen. This will take a number of parameters, the first being the handle of the graphics control. The next will be the X and Y coordinates that we wish to actually place this icon, as we specified up here. And then we're passing the name of the graphic we are actually going to load, in this case Hex1, the width and the height of that, and the handle of the bitmap mask, which we will need to use in order to draw the hex successfully. And after the for next loop is actually finished, we can close off the graphic bitmap command and then redraw the graphics control for our users. So the next thing to do is to create this new function, drawHex, which will allow us to see the hex button on the graphics control. So here is the skeleton of our new function, drawHex, with its parameters. So this is going to be quite a short function, as its purpose is quite well defined. First of all, we're creating a local variable to hold a bitmap handle. Then we're using the graphic bitmap load command to load the specified bitmap into memory and returning the handle to populate that new variable. Once we have that bitmap in memory, we can use the graphic copy command twice. One to define the mask source, and one to do the merge with the source. This should allow us to display our hex-shaped button on the screen. So our code compiles quite happily. Let's try running the application and see if we get our button. And there we have on screen our hex-shaped button. There is no logic behind this button at the moment, and that's what we're going to be doing next. We can also test that as we move the graphics control around the screen and resize it, the button remains as it is redrawn each time the control is repainted. So we'll go back to the code. So before we put any logic in to allow the user to click on the button, we'll draw the other buttons. So we can go back to the drawHex menu function and put the remaining functionality in to support the remaining buttons. So as we saw, we're populating this array, the locations array, with the positions of each button. So we merely have to do the same for the remaining 6 buttons. So for the second element, x coordinate, we're taking what was in the first element and we're adding on a value. This value is the width of our bitmap multiplied by 0.7. So we're taking 70%, adding on to its x location. And for the y location, we're adding on the height of the bitmap divided by 2. This is an integer division with no remainder, so we will get a whole number. So now that we've added on the second location for our hex button, we'll need to give it a name to know which graphic to load. So in the icon array, we're adding hex number 2. So we will change the constant max hexes from 1 to 2. This should allow us to draw 2 hex buttons on our graphics control. If we try running the application now, we can now see we have a second icon appearing on the screen. So we now just have to do exactly the same thing for each of the remaining hexes. So here are all the remaining locations for each of the hexes, from the first element all the way up to the 7th. And as we did before, we'll need to add on the bitmaps to be used for each of these buttons. As I've only created 2, I will just repeat these values in order to fill up the array. So there is hex 1 and hex 2 repeated a number of times. So we will now change the constant at the beginning of our program back to the value of 7. This should allow us to draw all 7 hex symbols on the graphics control. And there we have our cluster of hexes on the screen. We now have all 7 showing. So now that we've managed to achieve having each button showing on the screen, we now need to find a way of allowing the user to click on any of these buttons and allow us in the code to work out which button has been clicked on. So once more, back to the code. So of course, there are a number of ways of actually performing this action. But the way we're going to be doing this, as each hex on the screen is very close to a circle, all we really need to work out is where the very center of each of these hexes actually is. And we can store that information in a global array. And there is the global array we're going to be using. This is going to be a point array, as it's going to store the x and the y coordinates of each of the centers of each of the hexes. So where we actually put them on screen, we can work out where the center of each of these are in the Draw Hex menu. So within our for next loop, where we're actually drawing the hex, we know the starting positions of the hex itself, the top left-hand corner of the bitmap. So we can store in our global array the x and y coordinate being the same as the x and y coordinate for the top left hand, plus the width divided by 2 and the height divided by 2. This gives us the center location of each of the bitmaps that's being displayed on screen. So storing the center location allows us to use a little Pythagoras theorem to work out where exactly the user has clicked on and which of the hexes the click location is closest to. But we're going to have to dimension this global array. So we will go back to the PB main function and put that in place. So there is the dimensioning of our global array from the value 1 to the maximum number of hexes, which at the moment is currently 7. And we're dimensioning that as a point array, storing the x and the y coordinates. So how can we pick up the location that the user has actually clicked on the graphics control? Well, we'll need to go into the event handler of our dialog to put some code in there to handle this. So straight into the callback function. One of our first tasks will be in the initialize dialog section, where we'll want to pick up the Windows handle of the graphics control, as we're going to be using a couple of Windows API calls in here. So we're going to create a static variable to hold this value. And the use of a static variable means we only have to populate it once, and each time this function is actually called, the event handler, the value will be maintained. And we're picking up the location the user has picked by populating a variable called location, which is a point variable holding the x and y coordinates. And our plan is to use another variable called hex to store the value of the hex the user has actually clicked on. That will be a value between 1 and 7, and we can use this to determine what to do next. So in our initialize dialog function, we'll want to populate the graphics handle. And that can be done quite easily by using control handle. This command will allow us to take the dialog handle of our graphics control and populate the Windows handle, which we can use in our API calls. As we're going to be clicking on our graphics control, we'll need to make sure that the graphics control will notify us of any such click. So before we go any further in the callback function, let's have a look where the dialog was actually drawn in the first place. In here we have a control add graphic command, but there is no extra lines of code in here to say that we want notifications, so we'll need to put that in. And there is our extra line of code with the ss notify command in place. This will send any mouse clicks or any other events for the graphics control to our callback function, our event handler. So now we can go back to our event handler and put some code in. So further down the event handler, we have the WM command section. This is where process control notifications are handled. So we'll need to put something in for our graphics control to handle when the user clicks on something. So we can do that quite easily by picking up the control message. If it's STN clicked, then the user has indeed clicked on the graphics control. And this is where we want to pick up the X and Y coordinates of our mouse. And we can do that by using a couple of Windows API calls. First of all, get cursor position, which will populate our location variable. This is a point variable holding X and Y coordinates. And then we can convert the screen to the client area. This uses the graphics handle we've populated earlier and takes as an input the location. This will populate the location X and Y coordinates, giving us our mouse click location on screen. Next, we need to work out which of the 7 hexes on screen has the user actually clicked on. We have the X and Y coordinates, but we need to convert those to a number between 1 and 7. So we're going to call a new function called getHex. This will take as input the X and Y coordinates we have just obtained, and will return either 0 to say the user has not clicked on any of the hexes, or a value between 1 and 7 to say that they have. So before we create this new function, let's handle what happens after we get the return value. Since we know the value is going to be between 1 and 7, and we have already set up constants for that, we can actually put a select case statement in place. So if they've clicked on the one which equates to exit app, which is the value 1, we can show a message box on screen. Are you sure you wish to exit this application? If they answer yes, we can effectively end the dialog, which will end the application, as there is only one dialog in use. For the other values, at the moment we'll just put something on screen to indicate which of the menu hexes they have actually clicked on. For example, the menu, the reports, the web, the search, the message, and the save. So in order to get all this to work, we need to create this new getHex function. So here is the skeleton of our new function getHex, taking its 2 parameters, the X and Y coordinates, that the user has actually clicked on. With this, we want to work out the distance between the location we've clicked on and each of the 7 hexes on screen, as we've stored the center positions of each of these previously. And this is where Pythagoras' theorem comes in. So we're going to create a couple of local variables, one to hold the distance between what's been clicked on and each of the hexes in turn, and a second variable, long R, which we'll use to step through each of the values within the hex location global array. And we're going to create 2 more variables, one for shortest distance, which will store the shortest distance, and one to say we've actually found one which is shortest. And we will set the shortest distance initially as a large number. So next we will use a for next loop to step through each of the hexes and calculate the distance. So here we're doing a quite simple Pythagoras theorem to work out the distance between 2 points. We have the X and Y coordinates we brought in as parameters, and we have the stored locations in the global array for the center of each of our hexes. So if the distance calculated is shorter than the shortest distance, then we store the hex number in our found variable, and we repopulate the shortest distance with the distance we have just calculated. So by the time we get to the end of this for next loop, either the found variable will contain a value between 1 and 7, or it will contain the value 0, as in nothing has been found. So now that we have this code in place, have we done enough to allow our application to pick which of the hexes the user has actually clicked on? Let's run the application and see how far we get. So we have our 7 hexes displayed on screen. If we click on the center hex, it comes up, exit application, are you sure you wish to exit? Well, we'll say no for the moment, and we'll try the top one. It gives us the message hex, the save hex, the menu, the reports, the web, and finally the search. If we try clicking somewhere not close to the center of a hex, say for example here, it still gives us the save icon. So it seems to be working for clicking on the hexes. If we click well away from the hexes, it's still picking up values, it's still picking up the closest hex. So we need to put some kind of limit on which it can actually find. So this is a small bug, but let's go back to the code and see if we can fix it. So the shortest distance is returning a value, but we need to make sure we're really close to where this actually is. So the problem appears to be in this function. We are indeed getting a distance calculated for each mouse click. And as we set the shortest distance to a large number, we'll probably need to make this a smaller number. So in our getHex function, I think we need to pass a shortest distance value. So let's change this and add it on as an extra parameter, which means we don't have to declare it here or populate it. So let's go back to where this function was called. And I'm going to be passing this as an extra parameter, and I want to set this up as a global variable. So back to our code at the beginning of the application. And we'll mark this as a variable for handling the shortest distance for a click. So when we draw the hexes in the first place, we can actually populate this variable. Now we know the width and the height of our bit mask. So we're going to store the maximum size of a hex in this global variable, short distance. And we're going to make it equal to the maximum value of either the width or the height of our bitmap. And as all the bitmaps are the same size, this will work quite nicely. We're also doing an integer division by 2 to give us half the size. And in the getHex function, if we look in here, we're passing this in by value. So we're passing in the shortest distance value, which is half the size of one hex, and we're populating this local variable, shortest distance, by value. And it will change depending on which hex we're actually looking at. So this avoids the global value of shortest distance being updated. Every time this function is called, this value will come in the same. Right, with that code in place, I think this is working nicely now. So we can click on the center one, and we'll say no. We can click away to the side, and nothing is triggering until we get quite close to where the icon is. So having that as half the width of the bitmap appears to be working nicely. So in summary, what we've achieved today is on our dialog, which has a gradient fill, we now have 7 hex-shaped buttons. Each of the buttons will allow the user to click on or near them. This allows us to pick up which button the user has actually clicked on. And we can put code behind each of these in the select statement in the event handler, allowing us to assign functions to each of these objects. This gives you a slightly different way of handling a GUI design. Hopefully you'll find this code useful in your applications, but that's it for today. Thank you for watching.